All right, so we're solving systems of equations, and in this case, we're solving for 3 equations and 3 variables. So in our example, we have 4x minus 3y plus z equals negative 10, and that's our equation 1, and 2x plus y plus 3z equals 0 as equation 2, and negative x plus 2y minus 5z equals 17 as equation 3. What we need to do is we need to first cancel out or eliminate one variable, and it needs to be the same variable. So the first thing I'm going to do is I'm going to organize my problem in these boxes below. So I'm going to put a 4x here, minus 3y, and z, and minus 10. And then underneath that, I'm going to put my second equation, 2x plus y plus 3z equals 0. Now in this example, I want to cancel out x. So in order to eliminate x, I need to eliminate 4x and 2x. So I'm going to use multiples. So in order to cancel out 4x, I need negative 4x. So I'm going to multiply my second equation by negative 2. And that gives me negative 4x, negative 2y, and negative 6z equals 0. And that's going to cancel out. I'm going to cancel out that equation now. So draw a line through it, because now I'm not really so focused on that. I'm going to cancel out my x's as well. So now I have negative 3y plus negative 2y, which is negative 5y, and 1z plus negative 6z, or negative 5z, equals negative 10 and 0, which is negative 10. And I'm going to put that over here. So this is my column for my y, and this is my column for z. So this is negative 5 is going to go here, and negative 5z is going to go here, and negative 10 is going to go here. And then I'm going to do the same thing with equations 2 and 3. So equation 2 gets shared between equation 1 and 3 in terms of elimination. Since I'm eliminating x in the first set of problems, I also need to eliminate x in the second set of problems. In doing, homework problems or examples, other examples, you may think it's easier to cancel out y or z, and that's fine as long as you're choosing one to eliminate at a time. So now, since I'm canceling out x, I need to cancel out 2x, and I'm going to do that by multiplying my second equation by 2, because I know 2 times negative 1x is going to be negative 2x, and that'll be what will cancel out our 2x. So I'll just slide down a little bit and multiply. And it's moving. So negative 2x and 4y and negative 10z. And I forgot to bring down my constant. My constant here is 17. So let me put that back in there. So 2 times 17 is 34. And then I cancel. Right? I'm going to cross out my bottom equation, because now I changed it by multiplying it by 2. I'm going to cancel out my x, and then I'm going to add up my y column. So 1y plus 4y is 5y, and 3z and negative 10z or negative 7z, and 0 and 34 are 34. All right, and those go over here. So 5y minus 7z equals 34. Now what happens here is the y's cancel out. They don't always, this doesn't always happen, but in this particular problem, we don't need to do any additional work to cancel out this variable. So those go, -5 and -7 or -12, z, and that equals 24. Dividing both sides by -12 gives us a z solution of -2. So since I now solve for one variable, I can use that to solve for another variable. And right now, since I solve for z, my next variable is going to be y. So I'm going to plug -2 in for z in one of these first equations. I kind of like the second one, so that will look like 5y minus 7 times -2, or times, yeah, equals 34, or 5y plus 14 equals 34. And then subtracting both sides, 14 from both sides, gives me 5y equals 20, or y equals 4. So now I know z and I know y, and I'm going to plug those values into one of my original problems to solve for x. I think I used the second equation as my example. So the second equation was 2x plus y plus 3z equals 0. Let me put this last one in a different color. So let's see, that looks like 2x plus 4 plus 3 times -2 equals 0. And 2x plus, let's see, 4 plus 3 times -2, that's -6. 4 plus -6 is -2 or -2. And if I add 2 to both sides, I get the equation 2x equals 2 and x equals 1. So my solution is 1, 4, and -2.